Hello and welcome back to the fifth stream of the Let's Build a Car series. Today we're going to be working on modeling a 3D strut as well as working on the rear suspension components and getting a little bit closer to finalizing that rear hub assembly. Starting out today, we're going to work on developing a full 3D model from a two-dimensional sketch. This is a basic motorcycle coilover, 320 millimeters in length. I pulled the pictures off the internet. I haven't purchased the strut yet. I just want to get a close representative model. Eventually, I'd like to use joints and actually develop it into a working component and hopefully get the suspension working as well. I'm not sure if Fusion's going to be able to handle that or not, so we're just going to start with modeling this. So first of all, we're going to use the dimensions that are available to us on the supplier's website, and we're going to get the eyelets developed and modeled in 3D. We have their eyelet size as well as the overall thickness of the assembly. Next, we're going to develop a basic rod that just kind of acts as the main strut component, and then start to build everything off of that centerline axis. Next, we're going to just continue to develop some basic circles. Each of these correspond to an estimated size, if not previously marked on that document that keeps coming into screen. And I'm just going to extrude these into the basic shapes. These are all very simple operations. Again, there's nothing to really make this overly complicated. The coil or the spring that comes up is going to be something that takes a few extra steps. Really just kind of adds that extra touch to the model. Some of the things like the coil and having it modeled pretty close, I just like it. Makes the model look a little cleaner, and when you have the whole thing built in terms of the car, I think it's really going to make it pop a little bit extra. So this is the beginning of the coil or spring development. I really like this in Fusion. There's a few tools in here that I just think are super clever. You provide a few basic parameters and the coil is built right in front of you. The other one being building threads on an object. I use it extensively with my 3D printing. So this is really, again, just to kind of get it close. I'm using the axe to see there to get it all lined up. And then I'm going to slide it into place and kind of trim it down a little bit. Probably could have gotten this closer with its overall dimensions, but this was an easy enough way to trim the edges and to have that actual look where it's flat on the top and bottom of the coil, just like you would see in real life. So there it is. That's how you develop a coil, and we'll move on to that final reservoir cylinder at the top. Moving on, we're going to switch back over to the rear hub assembly. I really wanted this to become a flipped assembly from where it is right now, where the toe adjustment was actually in the back, and that would just help if there was any flex with that part, make a more ideal toe in a situation where you're exerting a lot of load on the car. It looks like right now I'm just going to keep it the way that you see it on the screen. All of these pieces are really made to be kind of quickly changed over, updated, or changed. So in the future, I may flip it, but it's probably for now going to be good enough. A lot of these components are very heavy duty, and I don't think they're going to cause any issues by having them in this configuration. Here I'm going to make some basic standoffs that'll eventually house the brake calipers, or where I'd ideally like them to be. At the end of the day, a lot of this is going to have to be whichever direction the calipers prefer to be. I'm not going to try to bench bleed these every time I want to change them out or change the fluids just because it looks better. They're going to go in a similar orientation to where they came from the factory in the car. So these are kind of just placeholders. You'll notice they also hold a nice spot for threading and tapping that bolt that's going to go into the top A-arm assembly, or where the toe adjustment is. Moving on, I'm going to begin working on the upper part of this hub, and I'm trying to change this up a little bit. What I'd like to do is actually drill and thread the holes that those rod ends are going to connect to right there at the top. So you can see here I'm going to actually extend this material out a little bit and then just taper it a little bit just to kind of make it easier to get to those lower bolts. There should be about 3/4 of an inch of bite for the hardware. I think that's going to be more than suitable. This may change, but right now I think this is going to be the cleaner, simpler way to do this, where I can just machine a little bit thicker piece of metal down to the tolerances that I need and really save a little bit of time on welding or reassembly. So the next step on this, and I'm going to actually put this off for a little bit in this video, but it's going to drop that fitting fixture that's above it, and that's really just a way to make a captive bolt. So I don't think that needs to be under or as strong. It's not going to be under as much force, but I am going to make a slightly different version that welds on there. The rod end is 21 millimeters, so there should be maybe a little bit of space to get a TIG welder in there and get it welded on both sides. If I'm not able to, then I'll have to find a different solution, which may include bolting it back together. But the bulk of the force is really going to be coming into that lower hub, and I think this top captive assembly is not going to be taking the kind of forces that the 2 lap welds are going to be suitable for. There's another scene in here where I initially made my own bolts, and I was going to make it a tutorial, but I decided that it's really not the way to go in this instance, and so I've deleted it out. This is a very strong platform. The fact that McMaster Carr's entire catalog is available and previously 3D modeled for you to use in your projects, even if you don't use their products, this is A, time savers, and B, it really lets you know exactly what you're getting if you do choose to buy through them. I'm about 50-50 on buying stuff from them, but I do like that if I have a tolerance item like this where I want to make sure that I can get a socket onto that product, I know that it'll clear around the other material in the area, so I'll probably end up using some, if not all, of the hardware from them. Here and towards the end of this project for the day, I started working on this broad end right here and kind of thinking about what the suspension angle was going to be. It's a little bit off track from what I was working on, but I just kind of wanted to see what it was going to look like, make sure there wasn't any immediate or pressing or concerning clearance issues. The part might rub or move. Eventually, once I get this all made up as joints, it's going to be a little bit easier to identify where problems are and that kind of stuff. But for now, I wanted to take a little bit of a break and kind of look at what this was going to be, as well as set myself up for next week. So next week, I'm going to actually be building my first rocker on the top, and that is going to be what connects that arm that's going up at approximately 45 degrees to the motion or location of the coilover. They have to make approximately a 90-degree change, and so the rocker on a bearing is really the way that we fix that. So next week you'll be able to see that if you tune in. Again, we do all our streaming 2 p.m. Eastern Standard Time on Twitch, and then upload Tuesdays 1 p.m. So here's bringing that part back into play with the captive nut. This was the last part that I worked on, and I really just wanted to see if I could get enough overlap to feel comfortable about doing 2 lap joints and making sure that there's enough material there to hold on to it. At the end of the day, this is really just to captive that rod end, and I think the majority of the force is going to be on the bolt going down into the lower hub.